Hello, I'm Ananda Rizky firmansyah. My NIM is 23B5050411147. I study at ITL Trisakti. Allow me to present entitled Procurement and Manufacturing. So first, let's go to the chapter overview. Procurement and manufacturing are two foundational elements of supply chain logistics. In this chapter, the authors emphasize that these functions must no longer operate in silos. Instead, they must be integrated strategically to align with customer expectations and supply chain efficiency goals. Procurement is not just purchasing, it's strategic sourcing that contributes directly to firm performance. Manufacturing is not merely production, it's a system of transforming materials into market-ready products that must align with customer demand, inventory planning, and logistics capabilities. Key emphases of the chapter: the evolving role of procurement as a value driver, manufacturing strategies for different demand environments, the need for integration with logistics to achieve cost, quality, and service excellence. Next is the quality imperative. Quality is a central competitive differentiator in the supply chain. Global markets, shorter product life cycles, and rising customer expectations make quality management more important than ever. Total Quality Management, TQM, is introduced as a company-wide effort to instill quality in every process and output. TQM moves away from inspecting finished goods for defects and instead emphasizes designing quality into every step of the process. 8 Dimensions of Quality, Bowersox et al. 1. Performance: how well a product does what it is supposed to do. 2. Reliability: consistency of performance over time and under varying conditions. 3. Durability: how long the product lasts under normal usage. 4. Conformance: adherence to specifications and standards. 5. Features: additional attributes that enhance product appeal. 6. Aesthetics: sensory aspects such as look, feel, taste, or smell. 7. Serviceability: ease of maintenance and repair. 8. Perceived quality: brand image, reputation, and customer perception. TQM connects quality across departments, ensuring that suppliers, production teams, and logistics partners are all aligned with customer-defined standards. Next is the strategic role of procurement. Procurement has evolved from a transactional, price-driven function to a strategic capability that supports competitiveness. It plays a critical role in securing input materials and services that match organizational goals for cost, quality, innovation, and sustainability. Key objectives of procurement: ensure continuous supply. Reliable procurement avoids production stoppages. Reduce inventory investment through smart ordering and coordination with logistics. Support product quality by selecting capable, certified suppliers. Leverage innovation, working closely with suppliers who bring technical advancements. Minimize total cost of ownership, TCO, considering the full lifecycle cost, not just the purchase price. Strategic procurement decisions can create long-term value, reduce risk, and enhance flexibility in adapting to changing market conditions. Next is total cost of ownership. TCO is a comprehensive framework for evaluating the real cost of acquiring a good or service, not just the purchase price, but every associated cost incurred from acquisition to disposal. TCO components: acquisition cost, unit price, taxes, and delivery fees. Transaction cost: administrative expenses for ordering and invoicing. Logistics and transportation cost, inventory cost, storage, insurance, capital holding cost. Maintenance and downtime cost, especially for machines, tools, or critical components. Environmental, disposal cost, recycling, compliance, hazardous material handling. Why TCO matters: a low unit price may lead to high maintenance or service issues, making it more expensive in the long run. TCO enables better supplier comparison and strategic sourcing. Next is procurement strategies. Bowersox introduces a strategic lens for procurement that moves beyond one-size-fits-all purchasing. Insourcing versus outsourcing. Insourcing is beneficial when control, intellectual property, or quality is critical. Outsourcing is suitable when suppliers can provide better cost structures or specialized expertise. Procurement portfolio matrix. This matrix categorizes purchases by their risk and value to the business. Each category requires a different strategy. Routine items: low risk, low value. Strategy of routine items: simplify, automate purchasing. Bottleneck: high risk, low value. Strategy of bottleneck: secure viability, dual sourcing. Leverage items: low risk, high value. Strategy of leverage items: use buying PWER of die count critical items. High risk, high value. Strategy of critical items: build partnership, long-term contract. Next is procurement logistics interface. Procurement and logistics must coordinate closely to support supply continuity, inventory optimization, and customer responsiveness. Key interfaces: just-in-time, JIT, requires tight delivery schedules, reduces inventory but increases reliance on logistics. Third-party logistics, 3PL, outsourced providers manage transportation, warehousing, and fulfillment. Performance-based logistics, PBL, suppliers are compensated based on outcomes, like uptime, not effort. Without proper logistics coordination, procurement strategies, e.g., JIT, can backfire, leading to stockouts or production delays. Next is manufacturing processes. Manufacturing processes vary based on product type, demand volume, and customization. Types of processes: 1. Job shop, custom-built items in small batches, e.g., aircraft repair. 2. Batch process, similar products produced in groups, e.g., bakery. 3. Line flow, high-volume standardized items, e.g., automobiles. 4. Continuous process 24/7 operations for uniform products, e.g., oil, paper. Each process type has different cost structures, lead times, and flexibility levels. Next is matching manufacturing strategy to market needs. Matching manufacturing design to customer demand is critical. Factors to consider: variety required, volume expected, desired delivery speed, customization level, trade-offs, flexibility versus efficiency, inventory cost versus responsiveness, customization versus standardization. Choosing the wrong process for a given market can lead to high costs or customer dissatisfaction. Next is manufacturing strategies. Different manufacturing strategies serve different levels of customization and response times. Engineer to order, ETO, custom product designed and built for each customer. Example for ETO, jet engine. Software make to order, MTO, standard design, but production starts after order is received. Example for MTO, furniture assembled to order, auto, components pre-manufactured, final assembly upon order. Example for auto, computers. Cars make to plan, MTP, produced to forecast, inventory used to fulfill orders. Example for MTP, packaged goods. Next is push versus pull system. Push system, driven by demand forecasts. Risk: overproduction, obsolescence. Requires strong inventory planning. Pull system, triggered by actual customer orders. Requires process responsiveness and fast cycle times. Minimizes waste. Hybrid models are common. Base products are push manufactured, customization is pull driven. Next is mass customization. Mass customization aims to offer customized products at near mass production efficiency. Enablers: postponement, delay final configuration until customer order is received. Modular product architecture. Standard components allow easy reconfiguration. Flexible production systems, quick changeovers and adaptable machinery. Example: custom Nike shoes ordered online and delivered quickly. Next, lean manufacturing. Lean manufacturing focuses on delivering more value with less waste. Types of waste eliminated: 1. Overproduction. 2. Waiting. 3. Transportation. 4. Overprocessing. 5. Inventory. 6. Motion. 7. Defects. Key tools: 5S, sort, set, shine, standardize, sustain, value stream mapping. Continuous flow production. Goal: maximize value, reduce cost, and improve quality. Next is Six Sigma. Six Sigma aims to reduce defects and variability using a data-driven approach. DMAIC methodology, Define the problem. Measure current performance. Analyze root causes. Improve the process. Control to sustain gains. Common in both manufacturing and procurement to improve quality and reduce costs. Next is design for logistic. Product design affects how efficiently a product moves through the supply chain. Design considerations. Packaging for efficient palletization. Dimensions for stacking and storage. Modularity for ease of assembly. Labeling for scanning and visibility. Goal: minimize logistics cost and maximize speed. Next is functional integration. To succeed in modern supply chains, companies must break down silos and align procurement, manufacturing, and logistics functions. Benefits of integration: faster response to demand changes, lower inventory and improved asset utilization, streamlined decision-making, enhanced customer service. Requires shared systems like ERP, collaborative planning, and performance metrics aligned across departments. Next is strategic impact. When procurement and manufacturing are aligned with logistics, organizations achieve greater agility and responsiveness, higher customer satisfaction, reduced total supply chain cost, resilience against disruptions. This strategic alignment turns operations from a cost center into a competitive weapon. Next is key takeaways. Procurement and manufacturing are no longer support roles, they are strategic enablers of customer value. TCO must guide sourcing, not just price. Manufacturing flexibility enables responsiveness without sacrificing efficiency. Cross-functional alignment is necessary for supply chain success. The next is the conclusion of all the material is. Conclusion: procurement. Procurement is no longer a simple purchasing function. It has evolved into a strategic component of supply chain management. Its primary focuses include ensuring continuous supply of materials and components to avoid production disruptions, minimizing inventory investment through just-in-time (JIT) principles to reduce capital waste, improving quality, as the final product's quality largely depends on supplier inputs, supporting innovation and technology by treating suppliers as strategic partners in product development, reducing total cost of ownership (TCO) by looking beyond purchase price, considering logistics costs, quality, product lifecycle, and supplier services. Conclusion: manufacturing. Manufacturing plays a critical role in aligning customer demand with production capabilities. Key strategies include engineer to order (ETO), make to order (MTO), assemble to order (AUTO), and make to plan (MTP), each influencing customer lead times and the level of production flexibility. Adoption of concepts like lean systems, Six Sigma, and mass customization to achieve high efficiency and tailor products to market demand. Process integration with logistics and CRM systems to ensure that production is not only efficient but also responsive to market needs. That's all for my presentation. I hope you can gain benefits and digest it well. Thank you very much.